So in this video, I'm going to show you how to flash an ESC with an Arduino. Let's go. So some of the things that we're going to need for this project are, we're going to need this is a printer cable that kind of end there with a USB, and I'll annotate this right there, what kind of end that is. We're going to need the ESC, some 24 gauge, and you can do like 22 and 26. I'm using 24 gauge silicone coated wire, or if you have them, the pre-made test leads that go into a breadboard. We're gonna need some male crimp pins. These are Pololu item number 1931. These are 0.1 inch housings. So the next thing we're gonna want is item number 1900. These are the single crimp connector housings. We're gonna use these to cover over the male crimp pins when we're done. As earlier stated, this is our 24 gauge wire, and I went ahead and cut these to 6 inches. You can cut them to whatever length you like. You're just gonna need long enough to get from the ESC to the Arduino. And the next thing that we're gonna want is the Arduino itself. This is the Arduino Uno version 3. Some of them have different inputs. We're gonna use the printer cable as shown earlier. And we're gonna want this pin header here. There's a couple of pins that we can use there, and I'll get into that a little bit later. To power the ESC, I'm gonna use this. This is just a jumper here with alligator clips. If you're gonna use this, be very careful with it, because if you plug this into a battery, I'm gonna use a power supply, current limited, and these touch, they will spark. So just be very careful with these, especially, even if you're just clipping these guys on here, it stands a chance that they could ground themselves. So just be very careful. I am probably gonna tape one with some electrical tape just to have it safe, and then just unclip and clip the other one to the computer bit of this. So you can use this, or you can solder direct if you wanted to put like an XT60 or something like that on there, and just to get it flashed. But this is what I'm going to use. Just a pair of nippers to clip our wires. We're going to want a crimper. This crimper is an iWise 0.1 to 1 millimeter all wire gauge, 28 to 18, part number SN28B. And we're going to be using the center, this guy right there. And then completely optional is a ruler to cut your wires to length. First thing I'm gonna do is strip back my wire. And I'm only gonna strip 1/8 inch. 1/8 inch seems to be about the number. And then go ahead and rotate the wire so we don't have any stray ends. Repeat that for all 4 sides. I'm only going to use 2 wires for this. You can do multiple ESCs at the same time, or so I've been told. We're only going to do 1 at a time. And just full disclosure, this is my second time messing with an Arduino, so we're both going to learn from this. But I am confident that we will get it, so that's why I'm making this video. Okay, next we're gonna want our male crimp pins. Now you'll notice that these are pressed together with a piece of flashing. That flashing is your friend. We don't want to cut it off. So we want 4 of these pins, and I'm gonna cut right in between. Let's see here if I can show you. So I'm going to cut right in between each pin, right in the middle of that flashing. And you'll see why in a moment. I am not going to cut that flashing off quite yet. So we got our 4 pins, and we can put this to the side. We are done with this for now. unless you are going to make more of these. And many of you might already have these.
And you can buy kits of these already pre-made. You don't need to do this. I just, I don't know where mine are, so here we are. So what we're gonna do here is we're gonna take our crimper. All right, so sorry if I'm like all over the place here with these tools. It's been a while since I've dealt with it on the side camera rather than an overhead camera. And it's currently 15 degrees out, so it's too cold to record in my garage. So that's why I'm doing this. So if you look inside of here, you'll see the bottom part is kind of rotated in like a half moon shape. And then there's a couple of, there's 2 rotations on top. You want the crimp, when you place it in there, to face like this. So each end on the top is rolled in like this, okay? So if we look at this crimp connector, you can see that it's just rolled steel. And I'm sorry, this light is a little bit harsh, but that's what I got. Yeah, you can barely see that. But anyway, these are rotated up like this. So you want to put the rotation down in that little slot. And what's nice about these crimps is they're ratcheting, so you can ratchet it to a position where this will fit in there. You want to slide this guy in until it butts up against that flashing, just like that. And these male pins are nice because you can hold them from the back as you do this. So what we're gonna do is I'm gonna take our wire, put it right in the crook of the male crimp pin, and push it all the way in. You want the silicone coating to actually get inside of the actual crimp. And then once you get that in place, go ahead and crimp it down all the way. Crimp tight, okay? And once you're done there, you can pop that guy out. Okay, once you're done with that, go ahead and cut the flashing off. Okay, so that's one. Go ahead and grab your crimp connector, cover. We're gonna want 4 of these in total for this project. And again, if you're using test leads, you can probably skip right over this, though I appreciate you watching all the way through because it helps me out. All right, so the way this guy works, on the side here, you have a little opened hole and then kind of a little notchy thing. The back is a nice wide open square. And the front is kind of a concaved hole. We want to take our crimp pin, and with the crimp side facing up, we want to place it into the square hole and push it in right up until the point where it clicks into place. And unfortunately, sometimes these ones, or my crimp connector will not crimp these all the way, so we might have to go back with a pair of pliers and just kind of seat them in place just a little bit better than they are, so that this will fit inside that crimp connector. What we don't want to do is crunch. There's a kind of a square portion here. That's what clicks into this piece of plastic here. We don't want to crunch that. Okay, and this, because this is a male pin, we can go ahead and grab it and pull through. If this was a female pin, we might have some issue. Okay, so now we have our crimp pin in place. Go ahead and repeat that for the other side. And that one fit great. Okay, so that's one wire complete. Do the same for the ground wire. So now that we have our 2 test leads with male ends on either side, we've got a ground in our signal. We're gonna go ahead and take our ESC. Now, if your ESC does not have this, you can
just uses wires direct, or you can put the male pins on this to go to this. But because mine comes with this and I don't have plans of removing these pins, I'm going to do it like this. It's up to you how you want to accomplish this. So we're going to take the ground and put it in the ground slot. We're going to take the signal and place it into the signal. Okay, just like that. Then what we're going to do here is take our Arduino, and right at the top of the board here we've got this pin header, and it's nicely labeled here. What we're looking for is, oops, right here. I'm going to take these wires out and show you exactly where I'm plugging these in. So if we look right here, there's an RX and TX. I'm going to go ahead and place the white wire in the RX, and then if we go all the way over here, you'll see that there's a ground, and we're going to place this wire right in the ground. This is the black wire in the ground. Okay, so when we're done with that, your connections should look just like this. Okay, and then the other thing I'm going to do is take my negative lead and my positive lead and connect this to a battery. Okay, so that's our connection there. So the other thing that we're going to want is the printer cable to plug into the Arduino to power that. So with this, I'm going to go ahead and plug the USB into the computer, and when prompted, we're going to plug in either a battery or I'm going to use a current limited power supply. We're going to plug that in here. The other thing that we want to be careful of before we do anything power related is I'm going to take the heat shrink and just cover this ESC just so we don't accidentally ground it out onto something. And if you have motor wires attached to this, you're going to want to make sure that those are isolated from one another, because those can ground out. So we're going to do that. So when hooking this up, this is 16.8 down to 8.2 volts. So you can hit it with anything in that range, probably on down to like 7 volts, 6 volts, something like that. So I'm going to hit it with like 12 volts, and I'm going to let the computer power the Arduino through this cable. So with that, let's go ahead and get to the computer. So go ahead and plug in your Arduino. As I said earlier, we want the printer cable plugged into it, and you should see a couple lights lit up on it. So the first thing that we want to do here is go to, if you haven't already, the GitHub file for BLHeli32, and we want this link specifically, which brings us to a mysterious looking Google Drive folder. This is legit. So what we want to do here is we want to look for the latest version. As you can see, this is Mac OS, this is Linux 64. We want this one here, 32.7.0.9 or 32709. Go ahead and download that, extract it, and run the program. And once you run the program, you'll get something that looks a little bit like this. Now, some of you will notice that I'm on a later version. This version should work on 709. I'm on 707, and we're gonna go over here to select BLHeli32 interface, and we wanna go and select K, BLHeli32 bootloader 4-way-if. Once you make sure that's connected, go over here to make interfaces. We're gonna select Arduino BLHeli bootloader. We're gonna go, if you're using the same one as me, the Nano W at Mega 328, and we're gonna set the baud rate to 115200. Now we're gonna go down here and select Arduino one wire Nano -328 hex file, and down the bottom we want to select our COM port that our Arduino is connected to. Yours may or may not be COM12. Highly likely that it is a different one. So go ahead and click this button here, Arduino BLHeli bootloader. And what this is this going to upload a sketch to your Arduino. So do we want to flash it with this on COM12 with that hex file? Yes. Click that. It's going to say Arduino flashed successfully. And please select BLHeli USB.com interface. So it's no longer going to be looking. I'll explain that in a moment. If for some reason that it says COM port not open or something to that effect, go ahead and play with these. You might have a different Arduino than I, where you need to connect to the 4-way interface. You might have a different Arduino board selected here, and maybe your baud rate's going to be a little bit different. So just play with some of those, and then if you're down here selecting the Arduino 4-way interface, sometimes there's a lot of hex files to choose through. So this is the settings that worked for me using the Arduino Uno. This is the version 3. Okay, so once you're done with make interfaces, go ahead and select bootloader USB COM, and then head over to ESC setup. Make sure the same port, so make sure the same COM port is selected. We can leave the baud rate alone. The next thing that we want to do is head over to the Project FDL GitHub if you haven't done this already. And they update this fairly often, so it might be a good idea to go check that and see when this was done. As you can see here, 11 months ago, the ESCs were, they added firmware to them. So these are safe to show you. What you want to do is clone or download that, put that somewhere on your machine, and then unzip that file, and then go through the file into ESC and then through this BLHeli 32. So this is where you get your INI file. So put that file somewhere where you know where it is. Once you get that set, go ahead and connect to your Arduino. And they want us to connect ESC power, so we're going to go ahead and cycle power to those. I just turned on my power supply, and that's going to give them 12 volts. Okay, as you can see, we're connected. Now we're going to go ahead and read setup. It's going to say ESC number 1 setup read successfully. Okay, and as we can see here, we've got SpeedX GS 30 amp version 1. And we are at 32.6. Okay, so we want to flash BLHeli. So click on that. And then that's going to show us the latest firmware is 32.7. Okay, so we're going to select 32.7 right there. And we're going to click OK. So it's going to ask you, do you want to flash this target? We're going to go ahead and click yes. It's verifying the flash. It's writing the flash. So there we go. That ESC is now flashed. We are not done. Now, the next thing that we want to do is we want to go here and we want to read setup from INI file. Just a special note here, ramp up power is 50%. So you know when this works. So we're gonna go to, this is where I stored mine, the whole tone dampening. Go ahead and click open. And as you can see, that set the ramp up power up. It changed a bunch of other things here. We have our music notes all set. Now we want to write setup. It will say ESC write OK, click OK. So that's all we need to do there. Go ahead and disconnect. So that's a look at how to flash your ESCs with the Arduino. The nice thing is once you flash that sketch to the Arduino, you don't need to worry about doing that again. This is now an ESC flashing Arduino. You can use it for other stuff just by reflashing a new sketch to it, but this is just going to stay the ESC flashing Arduino. So you can hook up one, flash that, hook up another one, flash that, and so on and so forth. So these ESCs are now ready to go into a build. The USB linker that I had shown in an earlier video is a good way to do it. The trouble is the actual USB link. Some of you have been having trouble with the communication ports. This speaks to the computer a lot better than that. So This is a little bit more expensive, but I mean, this thing still was around like 20 bucks, something like that. So I really think that this might be the actual good way to go. The other way is a little bit cheaper, and there's a few more hurdles to jump through, but this worked out very well for me. Hopefully it will work out well for you. This is an option for doing this without a flight controller. If you don't have one of those or don't feel like hooking one up, this will work out. So it has many uses. You know, if you just want to check things out quick, you throw this on there, bing, bang, boom, done. So yeah, there's that. Hopefully for my next video, I can actually get back to my garage. It's currently, I think, 14 degrees out in my garage. It's just way too cold. So we're hoping to get back out there. Many of you who are watching, you're interested to see. I got to get the Redshifter's Red Whoop 4K. I got to get that done. I was hoping to do that today, and I just ran out of time. The other thing I got to get done is the Slam Nasty. I got to fix that motor desync issue. So I'm hoping to do that probably like the next video, then my next filming day, hoping to get those two both fixed in the air again. And I think it's going to be a little bit warmer, so we're going to try to do that. But anyways, so let me know in the comments below, did this work out for you? If this was easier than the USB linker, or if you're just going to use that and that's working out for you. I'm curious to know what you guys are thinking. And if this video helped you out, if this is easier for you, give me a thumbs up. And if you haven't done it already, go ahead and punch that subscribe button, because you only get to do it once and it's fun. And I'll catch you later. Peace.